We're going to talk about compound inequalities, and compound inequalities will tie into what we just talked about with and or, intersection of sets, union of sets, that kind of thing. So if you haven't watched that video yet, watch that one first before you watch this one. So a compound inequality that deals with and. So there's two main categories, there's and there's or. And in this case, we're going to start with and. And one way that you'll see it is with the word and. So you'll have one inequality and another inequality. So it might look like this with an and in between, or it could look like this, which is a compound inequality. So remember when we were doing these just a few moments ago, we were talking about the answer would be between this and this. And so that's what's going to happen in all of the and questions. It's going to be between two different values. So taking a look at an and inequality, remember we're going to be looking for the intersection of sets. So the intersection is when we had our two Venn diagrams and it hit that middle part. We also talked about what that looks like with graphing. So if I were graphing x is less than 2, it would look like this. So it's the parenthesis at 2 shaded to the left. Greater than or equal to -3 would be a closed bracket on -3 shaded to the right. And remember, the and is the intersection. So we're looking for where are they both shaded? So that would be from here to here. So from -3 to +2, we would include the -3 and the +2. So this is the intersection of the sets. So we're going to solve one of these and graph it, and then we're going to tell what the solution set is. And of course, the solution set is the set of all of the solutions to our and inequalities. So here, we're going to solve this just like normal. I'm going to subtract 3 from each side. I get x is less than or equal to 4, and I'm going to add 2 to each side to get x is less than or equal to -1. Now what this and means, again, is it's all of the values that are in both x is less than or equal to 4 and x is less than or equal to -1. So let's take a look. If I have x is less than or equal to 4, that would look like this. And if I have x is less than or equal to -1, that would look like this. So where are they both shaded? Now in this case, most of the time we have two that are sort of going the opposite direction and we get that middle part. But here, if you'll notice, from this point all the way over, so I'm going to put a bracket here, all the way to -infinity would be my solution. So our solution would either be all of the x's such that x is less than or equal to -1, or in interval notation, -infinity up to -1, and of course include -1. Let's try this one again. This one I'm going to divide by -2. Because I've divided by a negative, we know our rule is to flip that inequality around. So I get x is greater than -3. And this one I'm going to subtract 5. X is less than or equal to 2. So again, not a bad idea to graph them both sort of above the line to see what you're dealing with. This one is an open parenthesis shaded to the right. Remember, when the x is on the left side, the arrow points in the direction you should shade. If you're not sure which way to shade, you can always do a test point and plug in a value for x and see if it's true, and if it's true, you shade in that direction. Over here we have x is less than or equal to 2. That would be a closed bracket on 2 shaded to the left. And of course the intersection, the and, would be where are they both shaded. So that would be from 3 to 2 and everywhere in between. So this is one of the ones that we're used to where we have two that are going opposite directions. So my solution would be all of the x's such that -3 is less than x is less than or equal to 2. Remember the less than or equal because it's a closed bracket. Or -3 to 2 in interval notation. Our next example has decimals, but it's not going to change anything about the way that we solve it. You just might have to use your calculator to divide. So for my first one, I'm trying to get the a by itself, so I'm going to undo plus 3.1 by subtracting 3.1 from each side. On the left, that gives me 4.4a. On the right, that gives me negative 15.4. So remember, it's a negative, and then we're subtracting, which makes it a larger negative number. Then I'm going to divide each side by 4.4. Remember that I'm not dividing by 4.4a. I want to leave that a there. I want these 4.4s to cancel to give me just one a. And I've divided by a positive, so even though my answer over here is going to be negative, I don't flip the inequality. And I get negative 3.5 when I divide. For my second one, same idea. I'm going to subtract the 9.1 from each side. That gives me negative 2.8a, which I just brought straight down, is less than negative 15.4. Then I'm going to divide by a negative 2.8. And on this one, I did divide by a negative, and so my inequality is going to flip to make it greater than instead. And when I divide those, I get 5.5. And remember, we're looking at an and here, so that's going to affect what our graph will look like. Okay, so if I have some sort of graph like this, I know that my first one is a is less than negative 3.5. So negative 3.5 is negative between negative 3 and negative 4, which is right here. So this is going to be an open circle or open bracket shaded to the left. This one is a is greater than 5.5. So here's 5. I have a horrible number line. Again, I apologize. But 5.5 is here, closed bracket, shaded to the right. Now remember, we're looking for where do these intersect? So where are they both shaded? So looking at the graph, there's nowhere that they intersect. There's nowhere that they're both shaded. And so this solution would be the empty set. So x equals the empty set, or just the empty set, or you might see something like that, which also means the empty set. Try this one on your own and see how you do. For my first one, yes, we're dealing with fractions, but that doesn't change anything. Remember that to get rid of a fraction, I'm simply going to multiply by the reciprocal. So negative 2/3, the reciprocal is negative 3/2. And I'm going to do that to both sides of this. And if you're taking a fraction times a whole number, you can turn it into a fraction if it makes you feel better. On this side, the negative 3 and the negative 3 cancel, the 2 and the 2 cancel, that gives me an x. I've divided or multiplied in this case by a negative value, and so instead of less than or equal to, it's now greater than or equal to. And an easy trick for dealing with fractions is you're going to multiply by the numerator and divide by the denominator. So I'm going to take 6 times negative 3, which is negative 18, and I'm going to divide it by 2, which is negative 9. So without even having to use your calculator and without freaking out because it's a fraction, just remember this means multiply and this means divide. It's just a way to shove it all together into one thing instead of having two separate operations. So I've got that, and same thing here. I'm going to multiply by the reciprocal of 1/2. So if I flip 1/2 over, it's 2 over 1. So I'm really just multiplying each side by negative 2. And on this side, those negative 2's cancel, and I get 1x, which is just x. Again, I've multiplied by a negative number, so I have to flip this to greater than. And then 1 times negative 2 is negative 2. So again, if it helps you, make your graph. And you don't have to make a graph, but I find that it helps most people to do that. So x is greater than or equal to negative 9, which would be a closed bracket at negative 9 shaded this way. And then x is greater than negative 2, which would be right here and shaded this way. So at what point are they both shaded? From here on, which means, and this is an open bracket, so which means my answer is all of the x's such that x is greater than negative 2, or in interval notation would be negative 2 up to infinity. This is another and notice that it's written a little bit differently. I wanted to show you one of these so that you don't freak out if you have to solve it. So you really have two choices. So I'm going to show you the way that I don't like first, and then from then on out, I'm going to do it the way that I do like. So the first way is to just make it two separate equations, or two separate inequalities. Negative 4 is less than 3x plus 5, and then 3x plus 5 is less than or equal to 10. So basically what I did was I made one equation or inequality here and one inequality here, and then you can solve each one separately. So I would subtract 5. On the left, I would get negative 9 is less than 3x. I would divide by 3 to get negative 3 is less than x. And of course, if I wanted to write the x first, that would be x is greater than negative 3. And then on my second one, I would subtract 5. So notice I'm doing the same step, subtracting 5. That gives me 3x is less than or equal to 5. I would then divide by 3, and I would get x is less than or equal to 5/3. And then if I were going to graph the solution set, it's going to be, because it's an and it's a compound inequality written in this way, I know it's really just between negative 3 and 5/3. So on a graph, that would be negative 3. 5/3 is closer to 2 than 1. So it would be a closed bracket here and an open bracket here and shaded in between. Oh, I should have done that on the line, but you get the idea. So that's one way to do it. Not my favorite way, so I'm going to show you the way that I actually prefer. So I actually prefer thinking of building the two walls. So every time you see an equal sign or an inequality, you've got a wall. So here, when I subtract 5, I need to make sure I do it in all 3 places. So it's really just going to save me a little bit of work, and I'm lazy, so I like to save myself some work. So negative 4 minus 5 is negative 9. Here I get 3x. This is still a less than. This is still a less than or equal to. 10 minus 5 is 5. I'm going to take this divided by 3, this divided by 3, and this divided by 3. So in the middle, I get the x that I wanted. Negative 9 divided by 3 is negative 3. And then obviously over here, I have my 5/3. So what I've done is I've saved myself a little bit of work, and I know for sure now that I'm really just shading the area in between negative 3 and positive 5/3. It's going to look like that. So that's the way I prefer to do it. If you want to break it up into 2 separate parts, you can certainly do that. So here's another one to try. Ooh. Just kidding. So here's another one to try. Again, I'm going to draw a wall. 2x plus 1, I'm going to undo plus 1 by subtracting 1. I do it in all 3 places. That gives me negative 4 is less than. In the middle, I just have 2x. 7 minus 1 is 6. And then I'm going to divide everything by 2 so I can get x by itself. And that gives me negative 2 is less than x is less than 3. So when I graph, that's between negative 2 and positive 3. And it is open on each end. And last one for you to try on your own. This one, of course, I was very mean and gave you a mean one to do all by yourself. But this one, I'm going to first multiply by negative 3. Everything times negative 3. Now what that's going to do here is get rid of that. So in the middle, I'm just going to have p minus 2. Negative 3 times 2 is negative 6. I've, however, multiplied by a negative, and therefore I have to flip this around. Negative 1 times negative 3, again I'm flipping that around, is positive 3. And notice how everything is less than. We always want, when we have it written here with all 3 parts, we always want it to be less than. Now I'm going to add 2 everywhere to get p by itself. Negative 6 plus 2 is negative 4. In the middle, I just have p. 3 plus 2 is 5. So if I were going to graph the solution set, it would go from negative 4 to 5. It would be closed, and it would be everything in between.